Hello students and welcome to Solving Multi-Step Equations with like terms on the same side. Our essential questions for today are 1. How can I solve equations that contain like terms on the same side of an equation? And 2. What types of solutions exist to an equation? And we are going to learn 3 types. In previous lessons, we have learned to solve one-step, two-step, and multi-step equations. Over the next 2 lessons, we are going to learn about 2 additional multi-step equation types and the 3 types of solutions these equations can have. We will learn about like terms on the same side and like terms on opposite sides. Previously, we talked about the step to solving an equation, and that was to use inverse operations to isolate the variable. And we talked about creating a do and undo chart to help us know what operations to use. But in actuality, with a multi-step equation, using inverse operations to isolate the variable is the 4th and final step of solving an equation. There are 3 steps that can be taken before using inverse operations to isolate the variable, and they are, in this order, to simplify the distributive property, to simplify like terms on the same side, to simplify like terms on opposite sides, and then to use inverse operations to isolate the variable. Today we will practice and focus on the second step and include the first step in the process. Just as a long-term comparison, we will be talking about like terms on opposite sides in our next lesson, and in this lesson we're talking about like terms on the same side. When we talk about solving these types of equations, even though they both contain like terms, they are solved differently. When we solve equations with like terms on opposite sides, we will eliminate one of the like terms. Whereas on the same side, we will combine them. We will treat them as if they were an expression. And I'll show you what we mean as we look at some examples. In this example, we will need to combine like terms that are on the same side and then solve, meaning by using inverse operations to isolate the variable. I'm going to draw a line down through my equal sign so that you can focus your eyes on the 2 sides of the equation. You can see that on this side we have one set of like terms, both containing the variable x and a constant, and on this side we just have a constant. So we're going to be focusing on this side because it contains like terms. When we have like terms on the same side, we will just combine those like terms. So what is 2x plus 5x? Well, 2x plus 5x is the same as 7x, so we can rewrite this side of the equation in an equivalent way by writing 7x minus 4 equals 24. We have not changed the value of the equation, we just wrote it in an equivalent way. And now if you look at it, this is a 2-step equation because it no longer contains like terms on the same side. So if you need to, we can still create a do and undo chart. If we knew what x was, we would have to multiply it by 7 and subtract 4. So to undo this equation, we have to add 4 to get rid of the constant and divide by 7 to create a coefficient of 1. So we'll add 4 to each side. Negative 4 plus 4 makes 0, and 7x plus 0 is just 7x. So 7x equals 24 plus 4, which is 28. Our second step in our undo is to divide each side by 7 to create a coefficient of 1. 7 divided by 7 is 1, 1x is just x, and 28 divided by 7 is 4. So the value of our equation is 4. And you can still substitute back in to see if it equals 24. So take 2 times 4, which is 8, minus 4, and 5 times 4 is 20. 8 minus 4 is 4, plus 20 makes 24. So you can still check your solution to the equation in the same way we did before. Let's look at another example. This example likewise has like terms on the same side, so I'm going to draw this line down to help you focus on just this side of the equation because it contains two pairs of like terms. Remember, if you ignore that 37 here and just looked at this side, you know that variables with the same exponent are considered like terms, so we have 8x and plus 3x. But you also know that constants are like terms, so we can combine positive 6 and negative 2 as well. 8x plus 3x makes 11x, and positive 6 and negative 2 makes positive 4. All we did was rewrite this side of the equation equivalently by combining like terms. So it equals 37. Now this is just a two-step equation. You can create your do and undo chart if you need to. So we have to multiply by 11 and add 4. So we have to subtract 4 to get rid of our constant and divide 11 to get a coefficient of 1. So take away 4 from each side. Positive 4 minus 4 makes 0, so we get 11x equals, and 37 minus 4 is 33. Divide each side by 11 to create a coefficient of 1, since 1 times x is x, and 33 divided 11 is 3. So the value of the variable is 3. Let's look at another example. Draw a line down through our equals so we can see this algebraic side of the equation has two pairs of like terms. We have negative 8d and negative 3d. They are like terms because they both have the same variable and the variable has the same exponent. And we also have constants of negative 11 and positive 2. So if we combine negative 8d and negative 3d, if you owe 8 and you owe 3, then you owe 11, so we get negative 11d. Negative 11 and positive 2 make negative 9. If you owe 11 and you pay 2, then you owe 9, and that's equal to 13. This is again a two-step equation because there are two operations acting on the variable, multiply negative 11 and subtract 9. So to solve the equation, we'll have to add 9 and divide negative 11. So add 9 to each side. Negative 9 plus 9 is 0, so we get negative 11d equals 13 plus 9, which is 22. Divide each side by negative 11. That creates a coefficient of 1, and 1 times d is just d. 22 divided negative 11 makes negative 2. So the value of the variable that will make this equation true is that d has to be negative 2. This is the only number that will make this equation true. Now, if you look at the left side of this equation with the algebraic expression, you can see that there is only one variable on this side of the equation, but there are still like terms here with the constants. So like terms do not always have to be the variable. They can be just the constants as well. So we just bring 2y down because there's no terms like it. Positive 4 and positive 57 make positive 61, and that's equal to 25. Now we're to a two-step equation, so we'll do and undo. We'd have to multiply y by 2 and then add 61. So we have to subtract 61 to get rid of the constant and divide by 2 to create a coefficient of 1. So subtract 61 from each side. Positive 61 minus 61 makes 0, so we get 2y equals, now negative 61 and positive 25. We owe more than we have, so we're going to owe the difference between them. So take 61 and subtract 25, and we get 36. So negative 36. Divide each side by 2, and we get y equals, a negative divided positive is a negative, and 36 divided by 2 is 18. So the value of the variable is 18, negative 18. Now, we are going to add the distributive property to our equation. So in this example, we are going to need to distribute Then combine the like terms that are on the same side, and last, solve the equation. Now, remember, when you distribute, you always need to look at the sign in front. So we're not just distributing 2, we are distributing -2. So we have to do -2 times positive 5e, which makes -10e. And -2 times -e, a negative times a negative makes a positive, and 2 times e is 2e. Bring the -9 down, as well as the 39. Now, we will combine our like terms. -10e and positive 2e make -8e. And bring your -9 down. Now we are to a two-step equation. We will need, and if you need to make your do and undo chart, you can do that. It would say times -8 and subtract 9, add 9 and divide -8. But some of you may be seeing that we want to eliminate this constant first. So add 9 to each side. -9 plus 9 makes 0, so we get -8e equals, if we add that together, we get 48. Divide each side by -8 to create a coefficient of 1. Divide by -8, so we get e equals -6. -6 is the value of the variable that will make that equation true. Now, in all the examples I've given you so far, the algebraic term was on the left side of the equation, which is where you will see it most of the time. So in this example, I put it on the right side. Makes no difference in how you solve the problem. In this problem, we need to distribute first. We are distributing the number 2 to every factor or every term inside the parenthesis. So we have 2 times 5a, which makes 10a, and 2 times -1, which makes -2. Remember, always look at that sign in front. We just bring down the -5a and the 28. So we have 28 equals 10a minus 2 minus 5a. Now, if we look at the algebraic side, we see like terms of 10a and -5a. 10a minus 5a makes 5a. So we have 5a minus 2 equals 28. Now we're to a two-step equation so you can create your do and undo chart. We would have to multiply a by 5 and then subtract 2. So we'll have to add 2 to eliminate our constant and divide by 5 to create a coefficient of 1. So we'll add 2 to each side. -2 plus 2 makes 0. So we get 5a equals 28 plus 2, which is 30. Divide each side by 5. It creates a coefficient of 1. 1 times a is just a. And 30 divided by 5 is 6. So we get 6 equals a. Let's try one more example. Then we will look at a few real-world examples and special solutions to these equations. In this example, we see those parentheses, so we know we must distribute. So we're going to distribute +4, notice how I grabbed the sign in front, to 9 and -c. So I'm just going to bring this -3c down. +4 times 9 makes +36. +4 times -c makes -4c, and that's equal to 22. We have like terms on the same sides. We'll combine those. -3c and -4c make -7c plus 36 equals 22. Now we're to a two-step equation since we do not have any more like terms. To create our do and undo chart, we'll times by -7 and add 36. Subtract 36 to eliminate the constant, and divide by -7 to create a coefficient of 1. So subtract 36 from each side. We get -7c equals -14. Divide each side by -7, and we get c equals +2. 2 is the value of the variable that will make this equation true.